Okay, this video is meant to help you through pages 1 and 2 of the math section of your final exam study guide. So I'm working on pages 1 and 2, starting with number 1. What is the growth factor of the function presented by this table? So your growth factor is what we multiply by. This is your multiplication number. So in order to solve for that, you are going to take any output and divide it by the previous one. So you're going to take that 9540 and divide it by 90. What that does is it tells me what was multiplied to get from 90 to 9540. So if you divide that, you get 1.06. So then if I want to just verify that, I can take another output, so 101.12, and divide it by the one before it, 9540. And that also comes out to 1.06, so that verifies it. So the growth factor is 1.06, which means that's what I'm multiplying by to get from one line to the next. If I wanted to know the percent growth, I just need to look after the decimal point. Because remember, percent goes 1 plus r. That's your growth part of your equation. So the r would have been 0.06 in that problem there. All right, growth factor again. So not growth rate. We don't want to solve for r here. It just says growth factor. So I want to do the same thing, 162 divided by 150. And that comes out to 1.08. Just verify it, 174.96 divided by 162. And that is also 1.08. Okay, so my growth factor this time is 1.08, which implies an 8% rate. If I needed to know the growth rate, I would say 8%. All right, number 3, you've set a goal of having 15,000 in 8 years. So this is a goal. If you estimate your investment account will have an average yearly growth of 8%, so this would be your rate, write an equation that could be used to calculate your starting investment. So we know that the starting investment is located at the beginning of the equation after the equal sign. I need to put my goal in where the y is, leave the a to solve, put in the rate 1 plus 0.08, and do the t power, which would be the 8th power. It doesn't say to solve this, but if I wanted to, I could just do 1.08 to the 8th, figure out what that is, and divide it under the 15,000. That would tell me what I started with. But it doesn't ask me to do that, it just says to write an equation. So this would be the equation, leaving the correct variable unknown. All right, you have 25,000 available to invest. That sounds like a starting amount to me if it's going to be invested. You want to retire in 8 years, so that would be your time. You estimate that your investment account will have an average yearly growth, so this would be your rate, and so we can put in all the things we know, right? We don't know the goal, we don't know the total amount at the end, so we'll leave that as y. I want to put the 25,000 after the equal sign, 1 plus 0.06 for 6%, and then 8 years. And just, well, what does it say? Just write an equation. Write an equation that could be used. So I don't need to solve that. If I did, I would just put it in the calculator and get an answer. But that one is good enough for that problem. All right, last problem on page 1. Your car had an initial value of 35,000. Over the past 7 years, it has experienced a 5% per year depreciation. So this word here means that it goes down. So I want to be subtracting in this one. What is the value of the car today? This time I do need to solve. So I don't know the final result. I do know the starting amount, 35,000. And it's going to be a decay or a decreasing function. So it's 1 minus. And then I take that rate and I make it 0.05. And then to the 7th power. So all I need to do is put that all in the calculator. Should get a number less than 35,000 since it is depreciating. And what I got here is 24,441 and 81 cents. All right, so that's the end of page 1. Go over to page 2. Your car had an initial value, 42,000. Past 5 years it is depreciated. Okay, so it's the same kind of thing. We're going to start with 42,000. Do 1 minus since it's going down. 8% is 0.08. And it's 5 years. Type it all up. I got 27,681 $1.42. All right, so those last two problems were basically the same, just with different numbers. Label each table linear or exponential. Look at the y column to decide. So what I'm looking for here is it increasing by the same amount, or does it appear to be multiplying by something to progress? So 18 goes to 30, 30 goes to 42, 42 goes to 54. That's going up by the same amount every time. So this one is linear. And the reason is that it's a constant increase by 12. And that's all you need to say to justify it. Constant increase. All right. Table 2, 25 to 75, 75 to 225, 225 to 675. So that is clearly not linear because those gaps are much bigger toward the end. So I need to test if it's exponential just by figuring out, is there something that I multiply by to get from one to the next. Now I can see that it's tripling each time. If you weren't sure, all you have to do is divide to figure out what it did, and then do it again to verify it. So it is in fact tripling. So this is exponential. And it is repeated multiplication by 3. Okay, table 3. Well, it doesn't look linear to me because it's only up 2 here and it's up 2.4 here. So it's not linear. Just have to test to see if it's exponential. It'll be a constant growth factor if it is. It's not 1.2, it's 12. Okay, and that equals 1.2. And it does repeatedly equal 1.2, so this is also exponential. It's a repeated multiplication by 1.2. Okay, look at the last one. So this one is linear. It's not increasing, but it is decreasing by a steady amount. So we'll call this linear. Constant decrease by 6. All right. Joe's portfolio contains a stock fund with an average annual growth. If you invest $1,600, what will the investment balance be in 10 years? Okay, it's very much like the ones before. So I have an unknown final amount. I know that it started at $1,600. And it grew by 3.7%, so that's 1 plus 0.037, and then 10 years. Enter that all in your calculator, you get $2,395. All right, so that's pages 1 and 2.